Okay, now we get into solving exponential equations. So, the key thing to understand about exponential equations and logarithmic equations is that they need to have the same basis. Sometimes you have to use properties of exponents or properties of logs to simplify first, then solve. Some equations you need to use inverse properties, some you do not. And the equations that require use of inverse. So the inverse of exponential are logarithms, either ln or log, and the inverse of logs are exponentials. All right, let's get started. Whoops. So here we have an expression, 5 to an exponent is equal 5 to an exponent. Since these bases are the same, you can ignore the bases now and just set the exponents equal to each other. And then just solve, just becomes a simple equation. So in this case, I would add 3x to both sides. And that leaves x is equal to -3. And then what you want to do is you want to check your answer. So plug -3 back into the original expression, right there, -3. -3 times -3 is 9. 9 subtract 3 is 6. And then -2 times -3 is 6. Those two equal each other. So it works. This next equation, this is an interesting one. Let me cover all this stuff back up. So look at what this says. 4 to some power is equal to 1. Well, if you think about that intuitively, 4, in fact, I think I did that right here. 4 to what power is equal to 1? Well, 4 to the 0 power is equal to 1. So you could do that intuitively. What would zero out this positive 1? -1. But another way to do it algebraically is rewrite 1. So 4 to the m plus 1 is equal 4 to the 0. 4 to the 0 is equal to 1, so we just rewrote that. And now that the bases are the same, you can rewrite m plus 1 is equal to 0, and then m is equal to -1, and then because intuitively we already checked, we know that that's correct. All right, that's it.